Hey there, welcome to the video on general physical properties of Mars. This video, the purpose of this video is to give sort of a big picture, give sort of the big picture view on Mars. And while I'm not going to talk about all the physical properties or even a majority of them, I think these are kind of some of the more important ones. And most of them that I'll talk about in this video, I'll also go into more detail in future videos. So the first thing I want to talk about, and as you see on this picture, you can see Mars compared to Earth compared to the Moon. Earth, Moon, and Mars here. First one I want to talk about is radius. So the radius of Mars is almost, on average anyway, almost 3,400 kilometers. So it's a pretty big body, but not as big as the Earth. Um, it's a little more than half as big as the Earth in terms of length. If I This picture is to scale here. So if I put up a line that goes across Mars, you can see that that takes up a little bit more than half of the Earth. So um, pretty big planet, but not as big as ours. It's actually, one of the smaller planets in the solar system, but still it's got a lot of land area. In fact, actually it has, a similar amount of land area as on Earth. Earth is mostly covered with oceans, but if you were to take all of the land on Earth and add up all the area, then you'd have a similar amount of land space on Mars because Mars doesn't have any oceans. So, um, yeah, so that's kind of cool. Mars is also, in terms of mass, less massive than the Earth. The Earth is about 10 times as massive as Mars. Its mass is 6.4 times 10 to the 23rd kilograms. And once you know mass and uh, like a radius or a diameter, then you can figure out the volume of Mars, and that will give you its density, because density is mass, kilograms, divided by volume, in this case cubic meters. And when you figure that out, if you divide those two numbers, you get a density on average of 3,900 kilograms per cubic meter. And this is actually much less than the Earth's density. It so happens that the density of the Earth is the highest of the planets in the solar system. So it's an interesting little fact. But we've sent a lot of probes to Mars, quite a few now, and we have opportunities still going on there as of 2012, and Curiosity just landed a few months ago. And based on observations, it appears that the materials on the surface of Mars are very similar to those on Earth, and so using that, we can assume that the density is also similar to the density on the Earth. I gotta sneeze. All right, I'm back. So we can assume that the density of the materials on the surface of Mars are very, similar to the density of those on Earth, and so that means that those surface materials are less dense than 3,900, which also means that if you go deeper into the planet, you'd have to have more dense material to average that out. That's how averages work. If you have a smaller number and a bigger number, they average out to something in between, right? And so that's kind of how that works. We'll talk more about the inside of Earth, and we're thinking that you know probably there's a lot of similarities to the inside of Mars, although Mars is smaller, and so would have had a chance to cool more quickly. But that's for another video. In terms of weight, if you weighed 100 pounds on Earth, because of the smaller mass and the smaller radius of Mars, you would weigh roughly 38 pounds on Mars. And so what that means is the gravity on Mars is weaker, and so moving around would be interesting. Take some getting used to. Pretty much anyone could probably dunk a basketball in a 10-foot hoop, but we don't really have any sort of reference point as to what it might be like to weigh this much, but we do have something sort of close. We've sent people to the moon, and while you weigh even less on the moon, if you were 100 pounds on Earth, um, there would still be some similarities. You'd be able to jump higher, although not as high as on the moon. Let's take a look at this video. You see two astronauts on the moon testing out their jumping ability while wearing these really heavy spacesuits, and you'll see kind of what comes about from that. All right.
we think so too.
We were going to do a bunch of exercise that we had made up as the Lunar Olympics. Show you what a guy could do on the moon with a backpack on. But
for a 380-pound guy, that's pretty good.
They threw that out. Yeah, jump flat-footed, straight in the air. 300, about 4 feet. Wow. Charlie, that ain't any fun, is it? That ain't very smart. Well,
we have a few minutes left, so we decide to do the Moon Olympics. I decide to try to set the high jump record on the moon. And as I start to do that,
about 4 feet.
I bounce a couple of times, and then I fall over backwards. And as I fall over backwards, fear strikes. If I split my suit open, I'm dead. As John helps me up, I get very, very quiet as I listen to the pumps and the oxygen flow in the suit. Fortunately, the suit holds, and my fear subsides.
That was pretty cool. They got some air there, huh? I think what Charlie Duke said, or the other guy said that that with the suit they weighed like close to 400 pounds. It was 380 pounds on Earth anyway, and so even with all of that, they were able to jump that high. Pretty impressive. So you wouldn't be able to get quite as much air on Mars, but definitely much more air on Mars than you would on Earth. So one feature about Mars that's very similar to the Earth is day length. On Earth, the day length, as you know, is 24 hours. On Mars, it's 24.6 hours, or about almost 40 minutes longer. Now, if we were to ever send people to Mars, this would make adjusting to this new environment a bit easier. It's still a little off, you know. For example, we just again sent the Curiosity rover to Mars, and it landed a few months ago, and so the people in charge of like managing Curiosity, driving it, and giving it instructions, they're all trying to stay on Mars schedule. And so what that means is, you know, one morning they may go to bed, or one morning they may wake up at you know, say 8 in the morning. If they keep the Mars schedule, the next morning they'll wake up at 8:40, and then the next morning at 9:20, and so their day shifts by almost 40 minutes every day, and that's a little hard to manage. Although it might not be as hard if you weren't living on a planet that wasn't 24.6 hours, but yeah, it's a little interesting. So in the Red Mars book, they handle that in a unique way. They basically say, we like 24 hours, so we're just gonna make this 0.6 hours disappear, and you know, we'll just have fun and do whatever we want for those 40 minutes, and they don't, or 36 minutes, and they don't even really, you know, they're not even on the clock per se. But you'd still see sunrises and sunsets at a very similar frequency and the same pattern. And what I wouldn't give, gosh, look how beautiful this is. This is, I believe, a Spirit rover picture. I forget whether this is sunrise or sunset. I think it's a sunset, but again, I could be wrong. But gosh, wouldn't it be amazing just to stand here? Kind of reminds me of almost of the Star Wars video where Luke is going out and being like, "Oh, I wish I could go out into space and be a hero and crap." Yeah, anyway, so yeah, that's a big similarity between Earth and Mars. Another one is rotation inclination, and you know, it sounds a little high tech there, but let me make that very clear what exactly rotation inclination is. Mars's rotation inclination, by the way, is 24 degrees, and just to start you straight off, the 24 degrees is the angle between this line and this line. If you make a little degree symbol here, angle symbol, that angle is 24 degrees. But what does that really mean? So we're focused on Mars here, and here's the Sun and the rest of the planets in the solar system. Well, at least Earth and Jupiter and maybe Mercury and Venus. Some of them might be behind Uranus and Neptune. But anyway, Let me get this flat here. So we got the solar system kind of flat, and so Mars is going around the solar system in this plane. If you think of like a big, big pizza, a big flat pizza dough that's been all spread out and spun out, think of all the planets as like pepperoni on the pizza dough, and then when you spin the pizza dough around, the pepperoni just spins around with it, right? And so that's what Mars is doing, but Mars is also spinning while it's going around the sun. Let me show you that real quick. Speed things up a little bit. See that? But you'll notice Mars is spinning at an angle. It's not spinning left to right, like in the same plane as the solar system. It's spinning kind of from up here down this angle along this line. In fact, the moons go around Mars in with the same angle, right? Which is it's not really a coincidence. And so this 24 degrees, this 24-degree rotation inclination leads to some physical properties such as seasons, right? By the way, this is very similar to Earth's. Earth is just about a half a degree less. If we zoom into Earth real quick, let me show you that. So we get the Earth in the plane of the solar system, and Earth is going to rotate down from up here down here. It's not going to go straight across left to right. It's going to go like this. Ooh. See that? So Earth is tilted as well, and that leads to seasons. And that's the main reason why we have seasons on the Earth. The Earth's orbit is not that eccentric. It is a little bit, but not that much. So the distance away from the sun, which changes throughout the year, doesn't matter that much for us. Mars, on the other hand, is, as I talked about in the orbital video, is pretty eccentric. The perihelion distance is much closer than the aphelion, and so Mars gets a lot more sunlight when it's closer to the sun. So that actually makes the seasons even more pronounced. There's a big difference between summer and winter in the hemispheres, and so another byproduct of that is planet-wide really strong winds, which lead to planet-wide dust storms. You can see this picture taken by the Hubble telescope in 2001. In June, it's nice and clear. You can see all the land features, like this dark line here, and you can see the poles. And in September, a few months later, you can still see the features. Like this is the same outline of the darker land and the lighter land here. You can still see the poles, but they're very obscured by a planet-wide dust storm. And so, yeah, you get that going on. And the last thing I want to talk about, very briefly, because I'm going to do a video on just the polar caps, is Mars also has polar caps like the Earth. And in some ways, they're similar to ours, like the Arctic and the Antarctic, but in other ways, they're different. Like they're made up of a lot of dry ice or frozen carbon dioxide, in addition to some water. And so that's kind of a unique feature. And these are very prominent. These are one of the first things that you may notice if you look at Mars through a telescope, and you get a pretty close-up view. So yeah, so these have been some general physical properties of Mars. And again, by no means is this all of the properties. I could have gone on for like an hour talking about different things, but I'll save some of that for more specific videos, and we'll go from there. I hope you enjoyed this one, and I'll see you next time.